Hi everyone. In this video, I'm going to talk about the activity that you guys did in order to kind of discover the ellipses. And then I'm going to discuss questions 8 through 11 on the next page. So at the top here, you had to manipulate these equations to get them into the circle formula, which is x minus h squared plus y minus k squared equals r squared. Now notice this does not have any coefficients, leading coefficients, no fractions in here. So the second, third, and fourth one all have something that needs to be done to them in order to get them into this form. So in the second one, if you multiply by 25 on both sides, you end up with x squared plus y squared equals 25, which is how I'm getting 0, 0, and 5. In the next one, if you multiply both sides by 16, you get x squared plus y squared equals 16. So that gives you 0, 0, and 4. And in this last one here, if you multiply both sides by 16, you get x minus 2 squared plus y plus 3 squared equals 16. So that one you end up with the 2 comma negative 3 as your radius or your center, and then 4 as your radius. Now, I saw in class on Friday, most of you were able to graph this circle correctly. It has a center of 0, 0 and a radius of 4. And then what's interesting here is you're given this picture, but then it shows you that the equation is not both over 16. Now the x squared is over 36. So what you should have recognized is that you end up with a longer axis here. So the circle gets stretched out horizontally here, which is on par with the fact that that value underneath x is larger. Now, what you don't know is that the longer axis here that kind of makes it into an oval, that's called the major axis. And then the shorter one is called the minor axis. On the next page, the question compares if you were instead given the 36 underneath the y. So I think you can probably see that since the larger number under the x made it stretch horizontally, the larger number under the y is going to make it stretch vertically or be taller. So if you take a look at question number 8, which you have not done yet, hopefully you can see that the center is going to be at 1 comma negative 2 because it's opposite of those values inside those parentheses. So if I plot 1 comma negative 2, I'm right here. And then the major axis talks about which one is larger. So 25 is larger. The major axis is going to go 5 either way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The question is, what is the length? The length is not 5, it's actually twice that, so it is 10. The length of the minor axis comes from the smaller number, and the smaller number is 9. The square root of that is 3, so I would go up 3 and down 3, which is kind of on par with the idea that when you had the values over 16 on this last one with the circle, this was telling you how far to go either direction, and so was this. So we went the square root of that denominator. So I got here by taking the square root of this, so that tells me 5, and here by taking the square root of that, so that tells me 3. So the length of the minor axis ends up being 6, and I can draw myself the ellipse by connecting all of these. I would argue that these are more difficult to draw than the circles. All right, so question 9, Jordan claims the previous graph can also be represented by the equation here. This is the equation of a circle. Yes, if I were to multiply by 25 times 9, 25 times 9, I think I get 225. If I were to multiply, yes, I would then get that equation. However, It's still the equation of a circle. There's nothing telling you one of these is longer than the other. So this would instead be a circle. No, it's a circle with a radius of 15. Just like parabolas can be written in different forms, so can ellipses. The general form of an ellipse is given by this here equation. So now we have it all multiplied out. The general form is multiplied out, but we can see all the information we need when it's in perfect squares. So can we rewrite the question from number 8 using this? So if I take x minus 1 squared over 25 plus y plus 2 squared over 9 equals 1. The first thing I want to do here is get rid of all of those fractions. So the least common denominator is 225. So I'm going to multiply by 225 on either side. And that's going to leave me with 9 times x minus 1 squared plus 25 times y plus 2 squared equals 225. Now, if I expand these two, I end up with 9 times x minus x squared minus 2x plus 1 plus 25 times y squared plus 4y plus 4 equals 225. And lastly, I want to multiply those numbers through. So 9x squared minus 18x plus 9 plus 25y squared plus 100y plus 100 equals 225. Now I can see here that I want 0 on one side, so I'm going to move the 225 over and rearrange everything so it looks like this. So I start with the 9x squared, then I go to the plus 25y squared, then I go to the minus 18x. So I've done this, this, this. Then I go to the plus 100y. Then I'm going to subtract 225, but I'm also going to combine 109. So I have 109 and negative 225, and that gives me negative 116 and then equals 0. So there is my answer there. All I did there was multiply it out. The only tricky part there is the fact that I had to multiply by that 225, which is the lowest common denominator between 25 and 9, which helps me get this out of fraction form. So it's nice to do this before we're about to do this. This is something that we're definitely going to have to practice. The difference between completing the square in circles and in parabolas compared to ellipses is now you're always going to have different coefficients, which leads to the fact that you have different axes with the major and the minor. So you're going to need to complete the square, but you're also going to need to factor out those values. So let's reorganize this problem. So I have the x's with the x's, 4x squared plus 16x, the y's with the y's, plus 9y squared, plus 90y. And I'm going to move the 205 over to the other side. So minus negative 205. So here I am. So I am going to complete the square, but as you can see in these original equations, I don't have leading coefficients. I end up having denominators. So I actually want to factor out the leading coefficient. So I've got 4 times x squared plus this would end up being 4x, and I'm going to leave that blank inside that factoring out. And then I've got plus 9 y squared plus 10y plus another blank. And now in the parabolas, you added and subtracted to the same side. Now in the ellipses and the circles, you're going to add to one side and then add that to the other side. Remember, we have to kind of neutralize what we're adding on. So we equals negative 205. And then I'm going to do plus blank plus blank. So what completes this one? X squared plus 4x, I would complete it with a 4. I added 4 there, but technically that is 16 because it's inside the parentheses. So I added 4 into this fold to complete the square, but it's technically 4 times 4. So I'm going to add 16 to the other side. And then in here, divided by 2, that would be 5. 5 squared is 25. I added 25, but technically I'm adding 225. So that's kind of the tricky part about the completing the square with the ellipses. You're adding a number inside these parentheses, but you then have to think about the fact that you factored something out and what is that number actually being added, and add that to the other side. So this ends up being 4 times x plus 2 squared plus 9 times y plus 5 squared equals 36. Now, at the very end, all of your ellipses end up being equal to 1. Notice equal to 1. On your last page, up here, you had equal to 1. So the general form of an ellipse, which you'll get through the notes, is equal to 1. So your last step here is going to be divide by 36 on both sides, which ends up canceling out with that leading coefficient. So 4 over 36 is 1 over 9. So you end up with x plus 2 squared over 9. And then 9 over 36 cancels out to make 1 over 4. So you end up with y plus 5 squared over 4 equals 1. And this is your circle, your ellipse, sorry, in that form where you can identify the circle center or the ellipse center and the major and minor axis. So you can see the center here would be -2, -5. The major axis would be horizontal, and the major would be a length of 6, and the minor would be a length of 4 because you'd go 2 in either direction. The square root of 4 is 2, but then 2 times 2 is going to be 4. So it would end up looking something like this with the center, and this would be 3 either way, and this would be 2 either way. So that is that. So you are going to go on to your next page. You're going to take the notes that are on Google Classroom. You're going to try these problems on your own. I highly recommend drawing a picture for number 2. I think you guys will be fine with number 1 and reference back what we just did for number 3. And then once you're done with that, you're going to go on and try 1, 2, 3 over here. All right.